The quotes from his call to Parsippany. So Parsippany backed Miller down at 7:30, but I think until 7:30 his heart was in the right place, and I think he was suggesting that it's time to order an evacuation. After that, he changed his tune. But at 7:30 in the morning, I think his heart was in the right place. And finally, we were not in our minds convinced that the core was totally covered. That's another indication that it's time to let the civilians know to head for the hills, and it didn't happen. Okay, last time where I think anybody of conscience would have ordered an evacuation is before 2 o'clock in the afternoon. Based on the core temperature, we've been over this. There's clearly hydrogen was being generated. It could not have not been happening. There's a good double negative. This is an important piece, the next two. At 12:20, the NRC asked TMI, what is the temperature in the core? TMI got back to them shortly thereafter, and they said, we don't know. The computer is printing question marks. And then they said, that means the computer is messed up. In fact, question marks meant that the temperature in the core was over 700 degrees. They didn't know how high, but it knew it was high, and it was another indication of a meltdown in progress. So the other piece of this is that two temperature indications were not in question mark. They were 599 degrees. And they never told the NRC that, hey, we got two that are still on scale reading 599. In fact, they said, the computer's messed up. Well, a couple minutes before 2, there was a hydrogen explosion. Now, the industry will call it a hydrogen burn, but it was a hydrogen explosion. In lay terms, there was a big change in pressure and a loud noise that shook the building. To me, that's an explosion. In industry jargon, it's a hydrogen burn, but it was an explosion. The NRC was informed 2 days later. Plant manager Miller was in the control room at the time, based on affidavits from 4 reactor operators. They all said Miller knew about it. And the control room shook. Now, when your building starts shaking, I think that's about the last indication you need that you really should let the civilians know to head for the hills. After that, it was unconscionable that an evacuation wasn't ordered on the first day. I would say 7:30, but even if you give them the benefit of the doubt at 2, an evacuation should have been ordered on the first day. Okay. Did the containment leak? What's wrong with that picture? This is the audience participation section. See the spike? This is not post-grad engineering here. There's a spike there. This is the containment pressure. This recording was available to the operators in the control room. And a little before 2 o'clock, there was a huge spike in pressure. The peak of that. What did I do? I'm back. Okay, I'm sorry. Hit the robot. The peak is about 28 pounds. It's not clear that that really is the peak. The needle was moving so fast it might have left the page. But the industry's position is that the peak containment pressure was designed for 40 or 50, so therefore the containment didn't leak. The peak was below it. There's a couple problems with that. Now what I've done on the next slide is I've cut out from 2 o'clock to about 4 o'clock, but this is the slide I'll essentially be referring to in the discussion. Well, to me, what's important here is that before the spike, the containment was pressurized. It was at roughly 2-3 pounds of pressure. That means it's containing, because the core is generating a lot of heat, and just like in a pressure cooker, the pressure's above what it is outside. After the accident, the containment goes down to 0. It sits at outside after that. Now, the rapid drop was due to core sprays going on and mechanisms to drop the containment pressure quickly. And on top of that, with a hydrogen explosion, it wouldn't stay high anyway. But after about 5 minutes, any of those pressure mitigating and energy removal systems were gone. So the accident should have, if the containment really had maintained its integrity, this line should be about 3 pounds higher than where it is. Okay, the same spike, I just shortened it a little bit. So the other piece of this is that's the containment pressure for the entire containment. There's something called subcompartment pressurization. This explosion didn't occur in the whole containment, it occurred in the subcompartment. Some photographs after the fact, 5 or 6 years after the fact, showed doors being blown off their hinges in a subcompartment. So it's very likely that a subcompartment could have exceeded 100 pounds per square inch. So what I believe happened, based on subcompartment pressure, is that a leak occurred in a portion of the containment wall, and perhaps not all through the containment, but a portion of that containment wall got a crack and started to leak. And I based that on the fact, a couple things, and I'm pursuing slides, but before 3 pounds, after 0, never recurring. 0 is atmospheric in this system. Now, during the trial, the plaintiffs hired Dr. Reitblatt from University of Bridgeport. Dr. Reitblatt's a structural engineering professor at Bridgeport, and this is what he said. A plausible release of up to 8 to 10% of the volatiles may have occurred due to the unavailability of the containment system at the time of the accident. So Reitblatt concluded that about 10% of the radiation within the containment leaked out at as a result of that pressure spike. I'll get to what that means as far as total radiation in a minute. But if you don't want to believe Arnie Gundersen, this guy's a professor of structural engineering at the University of Bridgeport. And his expert report is part of the trial transcript. Okay, to my mind that wasn't enough. So what I did was I went back into old plant data, conveniently provided by John Daniel, an industry expert, against me. So this is industry data I went back through. And I found 3 radiation detectors that went off scale within an hour after the explosion. Now remember, most of the radiation detectors had already gone off scale. I found 3 that were on scale that suddenly then went off scale immediately after the explosion. And they're, the first one recorded a 5-fold increase, and here's the numbers. You can trace it back. The second one recorded a 10-fold increase and then went off scale. And this one I think is the most interesting. This one doubled. And it was protected by 4 inches of lead. Well, 4 inches of lead will eliminate everything except the most powerful gamma rays. And so in addition to a doubling of incredibly powerful gamma rays, what this also shows is there had to be low-level gammas and a lot of alphas and a lot of beta that were also released that this instrument never picked up. So for those 3 reasons, the shape of the curve, Dr. Reitblatt's analysis, and this forensic evidence, I believe I can show that the containment leak. Yeah?
And where were those monitors located?
You'd have to go back in the transcript, but what I did is 2 of them, they were very near the containment. They weren't, yeah, I went in the annular gap around the containment and in areas right next to it in the auxiliary building. Yeah. How much radiation escaped is the last question. And I should preface this. I don't believe that there's a UFO in Area 51. I believe that Kennedy was shot by one guy, and I believe that 2 airplanes crashed into the World Trade Center and knocked it down, and there's no conspiracy on any of that. However, I believe that the data for 3 Mile Island on releases is significantly larger than is reported by the federal government. Okay, this is how Dilbert would explain it. The secret's in the spreading. We'll talk about that. You have to remember that there is no measurement of how much radiation was released. Every monitor was broken. It had failed high. It had burned out, like turning a camera toward the sun or something like that. Every radiation monitor in the plant had burned out on the releases. So what happens is that assumptions had to be made based on off-site exposures. And for instance, if I've got 7, I don't smoke cigarettes, but let's say I had 7 packs of cigarettes, and we were in a large auditorium and not a small room, then I started to smoke, and you couldn't see me smoking, but you could smell the smoke, and you're not downward from you're off to the side. And I asked you at the end of my smoking, how many cigarettes did I smoke? Well, you could make assumptions about the concentration of smoke and back calculate how many cigarettes. And there's a lot of assumptions that have to be made. But what has happened in 3 Mile Island is that a lot of assumptions were made, and all of them were non-conservative. They were all lowball assumptions, and I'll talk about that. So the key is the assumptions. Another Dilbert? And you can see Dilbert's my favorite comic strip. There's no more Dilberts. Okay. John Collins was a guy pretty high up in the NRC structure. And this is what he had to say about off-site monitoring. Collins said, my problem, the concern I have about aerial monitoring is that for the first 3 days, we were pretty much into a very static air condition. There was very little dispersion. When you're flying your helicopter and taking your aerial measurements, you're actually reading erroneous readings. I really doubt some of the measurements that were made. You know, if you watch a helicopter do a rescue, what happens? It's taking clean air from up above and blowing it down and pushing the water out. Well, the same thing was happening with the aerial surveys around TMI. The helicopter was taking clean air and blowing it down on the radiation detectors that hung below. I agree with Collins that whatever came off the helicopters is erroneous. Second is that the wind was very light, and this is important in a river valley site, and I think rolls into what Dr. Wynn will show. In a river valley site, in the morning, you get very, very static air, and the plume was meandering, but it wasn't traveling very fast, and that's a concern. More on Collins. Not only should we have good monitors, but also people who understand how to use them. That was a problem since day one. They get the data, and no one sits down and evaluates the data to try to understand what it means. This is the NRC talking about the data which was recorded off-site after the accident. And the last, and probably the most important, is they had to chase the plume in a car. Now, as I was explaining, the plume variation from the center of the plume 6 degrees off. If you miss the plume by 600 feet, you'd be measuring 1,000 or 10,000 times less radiation than was on the